So, welcome everybody, and I want a big round of applause for Fernando.
Oh, thanks, man.
I'm pretty sure that you are gonna enjoy the true story and the struggle.
Yeah, let's see. Let's see what happens then.
Good luck.
Thank you very much. Okay, cool. So, yeah, I was not expecting such a big audience, to be honest, because Martin is giving a talk about, some personal experiences about ITE. And last night we were both in the same situation. Like, we needed to finish up the slides. It was 1 a.m. and we were, grabbing an ice cream together and saying, man, procrastination, right? It always happens. So, yeah. First of all, welcome to the talk. This talk is based on some experience. I've been, doing some code analysis lately in the last couple of months, and I gathered some information which I wanted to share with you. How many of you are iOS developers here? Good, cool. Because this is not an Android-related talk. So hopefully it's going to apply to all of us here, and hopefully you're going to identify yourself with what I'm going to be telling you. So just a quick introduction. Again, I have a lot of information, I would say. I would try to squeeze it in 30 minutes, but happy to catch up later. Sit down. I'm going to be spending the next couple of days here. So my name is Fernando Cejas. Yeah, basically, I like to share experiences, mistakes that I make constantly. There's a lot, because I'm constantly sharing shit. So I'm unemployed, yes, now. Yeah, so I quit my job. I used to be a developer advocate. I'm still a developer advocate, but I'm not advocating anything, just software engineering, whatever. So you can find me on Twitter, GitHub. I have a blog that where I put material, again, about experiences and so forth. One thing I wanted to start with, I like to start my talks always with some kind of quoting. This quote here, bad code is always imprudent. The reason why I put it is in my defense. I might say some controversial stuff here, which is against this. So be afraid of that. Whatever I'm telling you, don't believe 100% that. This quote comes from Uncle Bob, Robert C. Martin. So basically, there's never an excuse to write bad code. We know that. So in order to get started, we're going to start with a real-life project. I don't know, in an ideal world, when we're working on software in general, how many of you experience this? So you have a project, you finish it on time, best code quality ever, and on budget. Perfect. I don't know you, but this is my day-to-day life. Honestly. And not even that. We have time to write additional features. We test it twice. We have that time. And even we could take 2 days off because we were on time, so we could enjoy nice weather and so forth. Is it what you're experiencing day to day? How many of you? Just raise your hands. So one there? Because otherwise, just come over here and just say, yeah. So if you're doing this, you unlock the superhero level. That definitely doesn't exist. And it was obvious that I was going to use this meme here, because this is a retro style. I'm a big fan of Batman. You will see some Batman stuff here, but Batman from the 1966, from Adam West, the original one. So this is not actually our reality, right? When we're writing code, when we're working on software development, and so forth. And there is one thing. This is my best Batman actor, the one I like the most. Do you know it? Yeah? You've never seen it? Oh, I'm getting very old then. This is from 1966, actually. And it was the first version of Batman. You will see it constantly here. But now it looks bizarre, actually, with all these special effects and so forth. But yeah, getting back to our topic. So we know that our software is terrible, right? We know it. I think all of us are experiencing here the same thing. Issues, legacy code, technical debt, and if you let me go deeper, anti-patterns, God classes, God methods. We are basically creating monsters. That's it, right? How many of you are suffering from legacy code here? Please, don't lie to me. So it's nice because we identify ourselves here. We are all in the same boat. So in order to understand how these monsters we are constantly creating, we need to understand, specific terms. I know that pretty much everyone here is familiar with the concept of legacy code, and for me, it's an overused term. There's many definitions, but I would say, the most important one is just code without tests. For me, it's like, how many of you are writing tests now? Okay, there's some people who are not. So please go and write tests. It should be an implicit process inside our engineering process. So code without tests is just legacy. It's impossible to refactor it, to improve it then, because you don't know, how that code should behave then when changing something. So there's other definitions like, legacy code, code that someone else has written. So that's let's say the formal definition, the literal definition. Of course, this legacy code makes code difficult to change, right? And anti-patterns, many people. But I would summarize this as like code without tests, There's a new concept now. Reckless debt. Have you ever heard of that? No? So this is I've seen this concept, and sometimes when you go to a company, some people talk about reckless debt. And it was a little bit misleading when I came across this concept. And then I just thought, what is actually reckless debt? So this is code that violates design principle. So that means every time we're writing code, we are writing junk. And that means reckless debt. But we're not doing it on purpose, as we are going to see with technical debt. It's just like because maybe you don't have the skill set of that. By having reckless debt in your code bases means that maybe you have a problem with your skill sets. Your team is not well trained, and you're just suffer from the lack of knowledge, and you're just writing junk, which you will have to pay in the future. So keep that in mind. But also, reckless dev and technical dev are used interchangeably. So if you come across this concept, you can use it as a synonym of technical debt. So, but we are here to talk about technical debt. What is technical debt in the end? It's a metaphor. It comes from financial debt. So that means that incurs into an interest. There's something that we need to pay in the future because you're getting something, and then the price for that is an interest that you will have to pay in the future. And this technical debt actually is the result of a bad choice when designing software. Sometimes, we're going to see specific situations here when it is nice to accept some technical debt, because technical debt is going to always be there. I don't know any code base without technical debt at all. So with that being said, just to close the definition, I would say technical debt is the additional effort and work required to complete any software development, any software task. You need some extra effort because you're suffering from bad quality or quality issues in your code base and so forth. So we saw what legacy code is, and technical debt is actually reflected on legacy code. That's a reality. We see our technical debt, reflected on the code we are writing. So let's get started with our real case scenario. When we are adding a new feature to our app, we're writing something new. We have two choices here, actually. The first one is the easy way. So what does that mean? We just decide to build it to get there faster. So we make some bad decisions. We write a little bit of messy code, maybe these temporary hacks, that 2 years later you will see there. You need to keep track of this. You're making a bad decision here because you need to get there somehow. Then we will see specific situations. And yeah, and it's bad design, but you should be aware of that. You should track that. And the hard way, of course, is the opposite. You decide, I want to be consistent with my current code base, or I want to re-architect something. I want to make it easier for future development to work on this feature, functionality, whatever. And it's going to take a little bit more of time, which makes sense. So that's why we as developers, we need to accept some grade of technical debt, especially for tactical reasons. I'm pretty sure that most of you have been in this situation where you need to ship something pretty fast because of marketing strategies or whatever, and you decide to make it a little bit worse in terms of code quality. But you need to get there. So you need to accept that. The problem is to not forget about that, because that's going to incur into some interest that you will have to pay in the future. Or in other use case scenarios, like I bump into, it's like, for example, when you're developing, you need to ship some kind of module or something, or a third-party library or whatever, and you're part of a small team, and you're contributing to a tiny piece of that. And since that must be shipped, your little contribution, and you don't have, it's a reality that you don't have maybe some time, or you're working on something else, which is high priority as well, because that's something that happens, right? It's reality. And you just, make sure that you write it faster with, some messy code maybe in order to get it there. And then you track that, and you will pay that interest in the future. So here's the thing. We are deciding kind of when to write bad code, when to refactor something, and so forth in order to pay this debt. But we want to detect or analyze our current code bases as well, right? There are specific tools that I'm going to be showing you that we can use to detect technical debt. It's curious because I definitely encourage you to, run this exercise. Just grab one of your code base and apply the tools I'm going to be showing here, and you will be very surprised what you find in terms of code quality issues and so forth. So the first one, we want to unlock the rookie level. This is the most basic building block, and it's static code analysis. So I guess most of us are using static code analysis. Yeah? So we know what that means more or less. There's a lot of tooling out there for static analysis. You can use something at IDE level. I know Xcode probably has some. We have Lint on Android, for example, but I'm pretty sure that there's something similar, or even the same with other rules that applies to Swift in this case. You can use it at a CI level. After compilation, whatever, you just check all these issues and so forth. And there's other tools as well that integrate well with GitHub straight, or you can, install on-premise on your data center, whatever. There's a bunch of things that I wanted to mention here. I don't want us to go pretty deep on each of this, But like I'm going to be mentioning, because we need to get familiar with this because of what comes up next. So one of the metrics that I'm using, or a bunch of them, are these ones. So cyclomatic complexity is pretty common. It basically, I don't know exactly how the algorithm works. It's something to investigate deeper if you're interested. But you should know that it basically gives you a number that has to do with how complex your code is in terms of different paths. For example, I think one part is like detecting how many ifs, a clause or conditions you have in your code. That makes it, of course, to have different paths over it. So that means higher complexity. Code coverage, we know what that is. It's the lack of unit tests, of course, is going to reduce the code coverage. It's code covered by tests, unit tests. This is something I'm not strong believer in, because we can increase the code coverage by just testing getters and setters. So sometimes it could be misleading, or it could raise false positives within our code quality. SQL rating, that's another measurement, which is from A, B, C, D, E. Those are the 5 different levels that you have there. A being the best, the highest quality, E being the worst one. Number of rule violations, this is, has to do with the tool, which is going to give you a number of, how much you have violated there. Bug count. This is very important because we know that the more technical depth, the less quality we have in our code, the more bugs there's going to be. So I think that the first thing you should be aware of is go to your code base and see how many tickets you have for bugs, because we're constantly leaving them there, right? And they're piling up all the time. I remember, I work at SoundCloud for many years, and most of the time I bring many situations out of that period, because we were suffering from a lot of technical debt. And I remember I was part of core engineering. And I used to work on core Android. And we had very different approaches. The iOS team actually rewrote the app. We were suffering from legacy code at all. Those apps were such a mess. And many times, there were a lot of lessons learned, and we took different approaches. On one hand, iOS decided to rewrite the app entirely from scratch. We decided to go little by little, refactoring. And I'm going to tell you why, and what's the difference between those approaches, and why they went one way, which was better, what were all the lessons learned out of that. Getting back to our code metrics, because we use all these things in order to detect, to analyze our code, to uncover, what our code was telling us. Such a mess. Cause of the delay. This I just left this one for last, because this is more manual. When we're making estimations in our sprints, let's say, and we had bad estimations, we say something's going to be done in 1 week, and it turns out it's going to be, or it turns out it's in reality 2 weeks. So we need to track that, because this is the cost of delay, of that delay that's maybe, is telling us that there is some technical debt there, blocking us from properly estimating. So we have seen, hold on, I'm going to go show you a quick tool here. Okay. So I've been diving a little bit. I wanted to use something code agnostic. I didn't want to go either iOS or Android. So I've been using Sonar. Sonar Cube is a new release of what it was called Sonar in the past, which is some kind of static analysis tool. So, and I bump into this, you can integrate it with GitHub. So I bump into this project, which is Monica. Monica is some kind of personal relationship manager. So if you're interested in that, you discover something new. So I've been, analyzing this code base a little bit, how big it is, how the team, contributes. It has a lot of contributors here. And I've been checking, bugs. This is entirely static analysis. So I've seen, and 45 bugs. And here, when I go, hopefully this is going to work. Internet, please. Demo effect. Yeah, connection. Oh, 43. They just fixed 2. Probably they're listening. Nice. So it was actually pretty interesting to see the trend because they introduced, they went from 0 till 55 bugs in, I don't know, it was 2 weeks. So something weird happened. We don't know yet. Or at least the tool is not, being so accurate in that. So with that being said, you can explore way more about here. I've been checking out the applications as well. But yeah, this is not the entire focus of my presentation. I want to spend more time on other tools, which is more interesting. But keep that in mind that you can go there, you can use that in your open source projects. It's free, and you will be very surprised about that. So let's go to the next one. We have static analysis code. It's the most basic building block when analyzing a code base. Then we wanna level up. We want to go to an experience level. This is something that we were doing at SoundCloud, actually, and it's called the Tech Dev Radar. It's pretty easy, actually. A Tech Dev Radar is no more than a meeting. We have created a Tech Dev committee. Someone, taking the technical dev was so big that we needed people to take it over. So a Tech Dev Radar, for me, it's pretty simple to use, and it comes from experiences from the team. So each member of the team is just gathering information or gathering some part of the code this person has been working on and writing down some notes about it. So you go to a meeting with the technical dev committee, the entire team. You just grab a bunch of Post-its, the entire team there. You just draw this on your board. So this graph here with 2 x's. So you have, x and y. This is going to represent the development time of a feature, of a functionality of your code, or some kind of part of the code. And this is going to represent how painful that functionality is in the code. So I remember suffering from this. I was part of core, and I was working on dependency injection within our code base. And this, these represent different features. So these are going to be the Post-its, let's say, that you're sticking there. And each member of the team is going to stick these Post-its depending on how this person considers the pain and the development time of that. So that means something which is here, or for example here, it requires a little bit of development time to fix it, but it's causing a lot of pain in the code base. So that means maybe this is good, because we're going to provide a lot of value by fixing this part, and it's not going to take a lot of time to fix. Whereas in this part, if we have something here, it means it's going to take forever. So I was working on the dependency injection, and we had this huge dependency graph being loaded at startup time of the app. And that was really painful, because we were having an impact on the user experience, right? I mean, the app would be delayed by 3 or 4 seconds until it would load the entire dependency graph. So basically, it's about creating these regular meetings, having a technical dev committee if you're suffering so much from this, and keeping track on what's going on here. Then we're going to see how we can address technical debt. For now, we are measuring. We know that it's there. We know what are the painful areas in our code base. And we want to keep track of that for now. So this is a technical debt rather. But there is one step more that we can do. And this is the guru level. This is the topic here. It's a bit more complex. And I would say, sorry, this should be applied to very complex and big code bases. This is called behavioral code analysis. Are you familiar with this concept? Have you ever heard of behavioral code analysis? No? That's cool then. So what happens then? When we were talking about static analysis, we're just grabbing a snapshot of our current code base, analyzing, seeing all these issues and so forth. But what happens then? This static analysis could tell you, yeah, there is some complexity in our code. There's some, critical path. There are some issues and so forth. But it's not really telling us if that complexity is technical debt. Keep this in mind. You might have a class, a super complex class, super legacy, but if that class is not being touched frequently, does that represent technical debt? Because no one is actually touching it. So we're missing a factor here, which is time. Time and behavior coming from many developers. What if you could detect how many times this file has been changed, or this file or this part of the code is being touched by many developers? This is very important because we can prioritize better and analyze better. So, of course, technical debt is reflected on legacy code, but not only on legacy code. We're missing the social part. We're missing that we work with people. We're missing there's always a team, there's coordination, there's communication, and so forth. It's not only grabbing this snapshot of your code base and that. So the behavioral code analysis, and we're going to be a very interesting tool. We're going to see a very interesting tool here. It considers the organization and the people. Are you familiar with the Conway's law term? So Conway's law, for all of you who don't know it, became more and more popular with microservices. It means that your communication style at an organization level will have an impact on your code base. So if your communication style is a mess, then that's going to be reflected in your code. That's why when you have microservices, you would have like specific teams having only one responsibility and so forth. That means the structure of your organization, it's cool, so your code base are a little bit better. We're going to see that. All this information, it's invisible in the code base. We see, yeah, all these ifs and so forth, but like, what about if there are some coordination bottlenecks, for example? Some teams, 3 teams working on a specific part of the code. And how we, as developers, interact with the code. We need to see an evolution of our code base. With static analysis, we're not seeing that. We just have this frozen picture of that, and so forth. So there's a bunch of things here. I don't want you to just, I'm not going to go now to each of this. We're going to see it in action, actually. So there is a very interesting tool, which is CodeScene. CodeScene, all what I'm going to show you here can be done using the command line. So the thing is about where do we get, or from where do we get this information about the social part? You need to think about our gold mine of information, which is our version control system. So on Git, we have everything. We have who has contributed to each specific part of the code, who has changed a specific part of the file, and so forth. So this is a lot of information, a very interesting information, which can give you a clue of how our software has evolved over the years. So this code scene, it's basically taking that information from Git. It's using an open source library. Actually, you can build it yourself, but I decided to go for this because it's open source, and it saved me some time from plotting all this information into these amazing graphs. So there is a bunch of examples here. They have different code analysis. We're going to check them out. For example, a messy one that I saw is from Microsoft. Sorry, Microsoft. But it's this MVC project. So I've been diving a little bit into that. As you can see here, well, it provides you some information about the project. MVC, it's a framework for creating MVC webs. It's for web. And I've been checking this out. So you can see, right? It's clear from yeah, you can see everything there. So there is some interesting stuff going on here. So if I go to this technical debt, I see what I call hotspots. Hotspots are basically part of your code which are very complex, and they are very complex and they're very frequently changed. So that's what I was telling you. I was checking. This is the code, the representation of the code base. So it's represented by just your folders. It's going to take your folder structure and it's going to draw all this. And all this, the more red a hotspot is, the more critical, the more complex, and the more frequently it's being changed. So that's something, it's telling us something. So a lot of developers are coming over here to touch this file. What if you want to refactor it? Then there's going to be a lot of overlapping. You will have to constantly merge that, and it's like, hey man, don't touch it yet because I'm refactoring it. Yeah, but there's going to be other developers touching and so forth. So for example, I've been going to this. You can go, zoom in, and I've been checking this one, which is pretty red, and you can see here the change frequency. So it has 125 commits. There's a lot of things that we can analyze here. We can see the code. We can see the trends, actually. And it's been, how it has been evolving over the time. For example, it got super complicated here, and it got a little bit better. So these are hotspots. So these are really good candidates for refactoring. Maybe you're having some problem here, and then again, you have another mega complicated class somewhere, but you don't want to touch it because it's been touched maybe once a year. So this is going to be more valuable for you to work on because you're going to unblock some teams, you're going to get better coordination, and so forth. So it's something to check out. Hotspots. So code biomarkers. Code biomarkers tells you information about a specific piece of code. As we have seen how complex the other class was, and we can see at a more detail here what is that complexity. So there is a bunch of things here, for example, it's telling us that. Remember that I explained you this measurement, this metric from A to E, yeah, which was SQL. What was the name? Yeah. Let me go back to the. Yeah, exactly. So these were one of the SQL rating. Yeah, exactly. So the thing. Yeah. Okay, there we go. So what we have seen here is it hasn't been better. So now it's an E, so it's a very low quality. The last month was still an E, last year was still an E. And it gives you more information about that specific method. Something else that I wanted to show you here is this temporal coupling. Temporal coupling has to do what happens when we are touching a file or a piece of code, and that leads to modify other piece of code. That's telling us something. You know, sometimes you touch a file and you have to touch another 3 files most of the time. Why is that? Maybe there is some inconsistency or some lack of modularization in your code. It's telling you something is wrong with it. Why? Every time I touch, you know, the login class, then I had to touch the scroll class or whatever. So these kind of things are putting, like here, graphically, you can see all the classes, and every time that someone touches this class, 3 other classes are being modified every single time, or at least 90% of the case. So it's a very deep analysis of the code base. But if you want to spend some time tackling technical debt, you wanna really spend that time on stuff that matters. There's another thing that I want to show you is the social analysis. So for example, these are all the committers of the project. Check it out. It's pretty curious because, for example, here, this guy, it's only communicated with 2 other members of the team, sorry. So it's weird because here you can detect coordination or communication issues between why, for example, this one is talking to only one person. Why there's some information exchange between only these 2 people. Maybe there is something to analyze here. It's telling us that that the coordination is not being well done. What else I wanted to show you? I mean, this is I know that it might be complex in the beginning, but I'm happy to sit down with any of you afterwards and analyze some code base. So just come over. Then it's what I want to show you. Yeah, I think we're having not enough time. So, okay, before I go into this. So this is a very deep way of analyzing a code base. You want to prioritize good. You want to use your time in a very effective way. So all these tools or all these measurements can be done via the command line as well. I'm a command line person, but in this case, all these graphics are super cool. So we can go deeper into this. Yeah, I wish I had like 2 hours actually to continue with this. There's an extra ball here as well. Another tool I wanted to show that it's pretty cool, actually. I have the React repository here. I think we are all familiar with React, right? I think we're lacking time. So I'm going to roll this. And this is pretty cool. This is real time, what is going on with our code base. Or it's actually reading the log. And as you can see, this is how the project started. And all the contributors, just going from one side to the other, touching this part, these examples, and so forth. It's pretty cool if you want to impress your PMs, because usually they don't understand technical dev, right? Or like upper layers, it's difficult for them. And it's interesting, for example, you can go to any point in time to just see what was happening. Usually I do some kind of summary because you can create videos out of this tool to see what happened during a sprint. And for example, there was not a lot of activity here, but like at some point I was checking, I don't know, it was September of, there was a lot of people or committing code or something that got popular or I don't know, at some point. And this is a pretty cool tool. It's open source. It's called GORS. So you can do a lot of things with this. I know it's cool, but I had to turn it off. And so the thing here, just to wrap it up, is how we pay technical debt. We said we need to keep track of it at a team level. We need to allocate time to address it, right? We need to To have meetings, we need to, at the beginning of the sprint, and so forth. And at SoundCloud, we used to have something which was called technical debt days, which we would spend time only addressing technical debt out of this analysis that I've shown you earlier. And at the company level, because that's another thing, we don't understand. Sometimes it is tough to explain what technical debt is for upper layers, for business, for example. They don't understand that. They don't understand there is a problem and we cannot speed up our development. So you had to educate people. I know that sounds easy, right? Make it transparent. You can use these kind of tools to just, put that into a screen and something like that and keep track of that. You can go to your PM and show, hey, look at how we have been working on this. We have been, committing a lot of code, but that was not enough. And you had to communicate that. Don't be shy. Just, go to meetings, take the leadership. It's the only way. There's no silver bullet here. And just to wrap it up, this is, for me, it's a technical dev. It's a ticking bomb. At some point, if you don't address it, it's gonna blow up. So, this is a 1 minute video, 2 minutes video, like a retro style from Batman. So it's about Batman trying to get rid of that bomb. And yeah, let's check it out. Oh, God. Why was not working then? Okay. This is Batman. Enjoy. A little bit more. The bomb is there. Looks bizarre, right? But it was in the 60s. It's one of my favorite scenes. So, and it was a superhero then. Oh, the guys with the trumpet, no, not this way. So, look at that. The bomb is terrible, right? It's almost there. There you go.
Some days you just can't get rid of a bomb.
That happens. There's Robin, of course. Such a such a superhero, right?
Batman! Batman!
It's all right, Robin.
Holy orphan!
Okay, I'm gonna get it here.
Fortunately, I was able to dispose of that bomb in the nick of time.
Yeah.
And shield myself.
So, what I want you to say here, it's not easy to get rid of this bomb, which is our technical debt. And just wanted to picture that, with one of my favorite scenes. Hopefully, at least you got some information here about how to get rid, how to address, how to tackle technical debt. It's a thing. I mean, I haven't seen any code base without technical debt. I can tell you more about all the experiences that I collected. But yeah, that's pretty much everything I have to offer here. And yeah, had to say thanks, and I think I got a little bit out of time, but yeah, thank you very much.